Well, welcome everyone to our Week 7 CS50 section. My name is Carter Zanke. I'm the course's preceptor here on campus. And the goal of these sections is really to help bridge the gap between lecture and this week's problem set. So the goal of today is to dive into more SQL to give you more practice writing queries, working with databases, and hopefully at the very end you'll feel prepared to tackle this week's problem set. Now, actually, this week 7 is one of my favorite weeks in the course. And I like this week so much because it's all about data. And data is often about real people, real things in the real world. So it's like this really good connection between computer science and how things actually work in the real world. It kind of brings these questions about how we design things, makes them all the more important because we're actually going to talk about real people, real students, real things in this world we're going to represent inside of our own programs now. So thinking about data and representing real people, let's actually take a look into a fantasy world, one in Harry Potter. And if you're familiar with Harry Potter, maybe you're familiar with the Hall of Prophecy, which is this place where all of the prophecies go to live and reside, a place where we're going to store lots of different prophecies. And maybe one of these prophecies is this place of where Hogwarts students, people who go to the Hogwarts School of Magic, will be kind of housed, where they're going to actually live during their time at Hogwarts. So let's think about how we might store a database of Hogwarts students inside of the different houses of Hogwarts. And if you're familiar, there's like Slytherin, Gryffindor, Hufflepuff, and Ravenclaw. And all these students live in these various houses here. So if we think of a database, we think of this space that is kind of maybe currently empty, but we could fill it with some things. So let's go ahead and call this space, for the sake of our discussion here, just roster.db. We're going to have some students in here, and they're going to go into different houses inside of this database. So all databases have some tables, some places that we're going to store data inside of them. And in this case, let's say we have this table, looks a bit like this. If you can see that, we have Adelaide Merton, who's in the house for Slytherin. And the head of the Slytherin house is this professor named Severus Snape, right? And down below in kind of row 3 here, we have Anthony Goldstein, who's in Ravenclaw. And the leader, the head of Ravenclaw is Phileas Flitwick, a professor at Hogwarts School of Magic. So here we have a table, and often in our databases, tables are names. So let's maybe call this one students. And now we have our full database. We have a name for our database, roster.db, and we have a table inside of it, this one called students. But what we might want to do with this table? What are some things we might want to actually do to this data? If you want to chime in the chat, what's the point of storing data in this way? What could we do with it? Yeah, so I'm seeing somebody messaging me. So we could maybe actually try to figure out what else is inside of this data. We could query the database. We could try to ask what's inside of it. And to do that, we can actually use these SQL keywords that begin with a select. Like, how do we select data from this table? So let's dive into selecting data from tables. As we saw in lecture, let's go a bit more deeply into it this time. So if I wanted to select all the data from this particular table, does anyone know what kind of query I could use for this? Seeing in the chat, I'm seeing some selects, which is good. I'm seeing some stars, which is also good. And now let's go ahead and try this out. So if I go to my own VS Code over here, I can see that I have my own roster.db. So I'll go ahead and open this up with SQLite, this kind of database engine we can use to execute SQL queries on this database. So I'll do SQLite 3 roster.db. And now, just to show you, if I type .schema to see the kinds of tables I have inside this database, I see I have this table called students. It has the very same attributes or columns we saw earlier in our visual back here. So the hypothesis right now is we could kind of select everything in this table using this syntax I see from the chat. We could say select star, which means select everything from this students table. So let's go ahead and do that. And we end all of our queries in SQL with a semicolon. So this is the end of our thought. This is our entire query. Select everything from this students table. I'll hit enter now. And now I can see, kind of, if I zoom back out, all of the students who are inside of this roster. So if you scroll through, we have about 40 students here. And we see some of that very same data. So we see that Anthony Goldstein is in Ravenclaw, led by Phileas Flitwick. We've gotten all the data from inside this table. So that's pretty good. Let's get a visual for this. So if you said we had this roster here with a table called students, if we do select star from students, what we'll see is the entire table. We'll select everything in this kind of yellow highlight here. But we could also get more specific, because it's often not good to just select everything. Often we care about some particular set of students or particular column in general. So let's say I just wanted the student names. Like, how could I get the student names from this list, just disregarding the house and the head and whoever else is in this database? How could I just get student names? I'm seeing some where, and that is true. We could use where for other cases, but here I just want to get all of the student names from this roster. Nice. So I'm seeing some syntax here that looks a bit like this. We could say select student name from students. So often when we use select, after we say select, we have a column name, like the column we want to actually select from our table. So in this case, if we looked at students table here, we have a column called student underscore name. So if we want to select that column, we could say select student underscore name from this table called students. So if we go back to our SQLite prompt here, we can actually type in SQL commands. I'll maybe now type select student name from students. And what should I end this with now? Because it's a SQL query. A semicolon. Good. So I'll hit semicolon here, and I'll hit enter. And now, notice how my table just has that single column. It doesn't have every column now, but just that student name column. So often when we're using select, we want to include the column name we're selecting from our table. And if we just want everything, well, we can say star. Select star, meaning select everything from our given table. OK. Now, to kind of focus in on getting particular students, let's say we cared not just about every student's name, but only those who are in a particular house, right? If we go back to our table here, we have student names, houses, and heads. So maybe we care about the students who are in Slytherin house. How could we find the students who are in that house? Any ideas? We just care now about students who are in Slytherin. Yeah, so here we can bring back that where clause that we saw before. So if we want not just an entire column of students, as we see here, but some rows, depending on a certain condition in another column, we can use where. So where will give us back only certain rows from our table. So let's try this. We could say, let's select student names. Let's get that student name column from the students table now. But let's go ahead and get only those students where the house is equal to what we're going to call Slytherin in this case. So if we go back to our table now, and I type this query, I could say select student name. And I can type this all in one line for the sake of argument here. I could say from students, and let's do where house is Slytherin. OK, my query will wrap here, so it'll kind of go around the edge, but it's all one line, theoretically. I'll hit semicolon here. What do we see? Well, we see only the students who are inside of Slytherin. And just to prove this, let's go ahead and actually update our query. And let's show you how it can do it on multiple lines. So we could say select student name and house. We could say student name and house. We want these in the same query here, separated by a comma. Well, let's get this from our students table. And let's say we only want the rows where that house column is going to be Slytherin in this case. So I'll do a semicolon here, and I'll hit enter. And now I do see that these same student names do belong to Slytherin. So with select, we can always try to select not just a single column, but also multiple columns separated by commas here. OK. Now, what questions are there so far on these selects? Or does it seem pretty straightforward so far? Any questions in the chat? OK, not seeing any right now, but let's try to go a little more advanced now. So we've seen how we can select some data. We've seen how we can kind of get different rows back from our table. But what if we're not kind of sure exactly what we want to look for in our table? Maybe we want to get just the students whose last name is Potter. Well, how could we do that? Any ideas what kind of clause we could use if we want to find the students whose name end with Potter? So I'm seeing somebody says we should use like. And as we saw in lecture, like is this query that kind of lets us do a fuzzy match, meaning that we get all the rows that kind of roughly match some clause or some string we might give to our query here. So to do this, let's go ahead and look at our table again. For Slytherin, we got kind of a result like this. But now let's look at how we could use like. So if we're interested in students whose name ends with Harry Potter, well, we could do a query like this. We could say select student names, obviously, from our student table. And now we're only going to get the student names that are like Potter with this kind of percent sign in front. And does anyone recall what that percent sign is doing for us here? If you want to chime in the chat. Why can we not just say like Potter? And why do we have to say like percent Potter? Yeah, so I'm seeing that people are calling this a wildcard character. And basically, this percent sign says that I can match any character ahead of this string Potter. It could be Harry Potter, it could be Lily Potter, it could be really any name as long as it ends with Potter. And putting that percent sign at the beginning, well, that says that I can have any characters I want before Potter. And similarly, like maybe just have like Harry and then percent sign after Harry, and that would give me all of the names that begin with Harry in this case. So let's go ahead and take a look at this. We could say select student name now, and we want to take student name from our students table. And then after this, let's say, OK, we want to get the student names that are like, not equal to, but like this string we're going to give called Potter. Percent Potter, meaning we can get any character before Potter as long as at the end we see Potter exactly. So I'll hit enter now, and we see that there's really only one student whose name ends with Potter, which is Harry James Potter. But you might also see other characters in the Harry Potter universe whose names also end in Potter too. Now, maybe a better question here to get more students in this query is this one. So we could say, find the names and houses of students whose names begin with H. So let's try this one. We're trying to find students whose names begin with H. So we want to select, again, names. So I'll say, OK, I want to select a student name for my student name column. And I also want to select the house. So I'll say comma house. And I'll get back now in this query student name and house. Where am I going to get this data from, though? Any ideas? Where am I selecting from in this case, in the chat? From students. So I'll say from students here. OK, now to finish this off, I only want the students whose names begin with H. So I could say where to kind of subset my rows, get a certain number of rows who only meet a certain condition. And now the column I care about is student name. And I'm seeing in the chat, I could say not equals, not particular H here. I don't want students whose name literally is H. I want students whose name is like H, and then any other characters that come after it, right? So I could hit enter here. And now I'll do this. And now we see we have Hannah Abbott, whose name begins with H. Harry and Hermione also begins with H. And there are H in Hufflepuff for Hannah, and Harry and Hermione are in Gryffindor. A question, is this case sensitive? It's a good question. Let's go ahead and try it. So we could say select student name, and we're going to select also the houses from the student's table where the student name is like, and we saw capital H beforehand, like this, but now let's try a lowercase h and see if we get any students here, or any different results now that it's lowercase. So let's hit enter now, and we still get the very same results. So what do you think? Is like case sensitive? Does it matter what case I use? No, it doesn't seem to, right? I could use the capital H, I could say the lowercase h, and I get the very same results here. So that's a great question. And now I'm seeing another question. We need to use keywords like select, like where in all caps. And why is that so? So here you'll see that I'm using select in all caps. I'm using from in all caps. I'm using where in all caps, and like in all caps. And what the convention here is that if you're typing in a SQL keyword, some kind of command to SQL, like select or from or where or like, well, you should capitalize that to denote it as a SQL keyword. I can keep my column names, though, or my strings kind of in lowercase, because if I look at my table here, well, these literally are in lowercase. Student underscore name, house is lowercase. So I want to make sure that casing matches there. But for a SQL query, I should, by convention, sort of capitalize these keywords. I could very much do this. I could say select star from students, and I would get the very same results if I zoom out a bit. But it's just not quite as clean. It's hard to tell, let's say, if I do this, select student name, house, from students. It's kind of hard to tell where my keywords begin and where my column names actually join in. Like, it's hard to tell what thing is which here. So always capitalize your SQL keywords as you go through. Great. Another question, when do we use like? So as we've seen before here, we use like. Let me actually just finish the query here. We use like when we want to actually kind of fuzzily match something, kind of roughly match something. So if I know that I want students whose name begins with H but isn't exactly H, like is a good use case for that here. Other questions on selecting then? Just scrolling through the chat here to be sure. All right, so I think that's most of our questions on this. I'll just make a question about, is there a way to make search case sensitive? There is. So we saw before that like is generally not case sensitive, but let's try this. If I do a search for Harry James Potter, who we know is in our database, I could do select the student name from students where the student name is exactly Harry James Potter, and I'll hit semicolon here. And I should get, well, none other than Harry James Potter. But what if I did this? What if I said select student name from students where the student name is now all lowercase Harry James Potter, hit enter now, and no one seems to match that exactly. So equals, when you're using that, is case sensitive, but like by definition is not. Okay. So that seems to be most of what we might want to use our selecting for. We can use where, and we can use like to kind of narrow our matches from our table. But what else could we do with these queries? So one thing we want to do, as we saw in lecture, is kind of order our students, put them in like alphabetical order or kind of roster order and so on. And we can use some new SQL keywords for that exactly. So we can not just select, we can also order our data. So we saw before, we can just kind of get every student we want to. We can say select star from students, give us all the students here. But at the very end of this query, once it's complete, we kind of tack on this other keyword called order by to tell SQL what column I want to sort this data by. So I'll get every column, but if I want to sort the data by a particular column, I could say order by that particular column name. So here, if I do this, order by student name, well, I should get the names in alphabetical order. So I think if I select everything, select star from students, I might already have these names in alphabetical order just by virtue of how they were added to this data set. But if I were to do this, select star from students, I'll zoom in down below here, zoom in here, select star from students, and then order by student name, well, I kind of get the very same thing, but it's important to keep in mind that when you use order by without kind of anything after it, like this here, we're getting the names in what's called ascending order. So ascending in SQL means from kind of the lower ASCII value, like A, to the higher ASCII value, like Z. So A to Z in this case. But if I wanted to flip it, not having A to Z, but Z to A, well, I could change this not to order by ascending, but to order by descending, like this. So by default, SQL will always order by the ascending order, like this. But if you want to order by descending, you could simply say descending at the end, or DESC for descending. So let's try that now so I can actually see the results. So I'll go clear my terminal, zoom in a bit, and I'll say select. I'll say select star from students. And then I will say order by student name, now descending. So from Z to A. Now let's try this. I'll hit enter. And now if I zoom out, you should see I start with Vincent now, whose name is towards the end of the alphabet, and I go up to Adelaide, whose name is at the top of the alphabet in this case. And I mean, there are other things we could sort of sort by here. So we don't have to just sort by student name. We could also sort by house. So maybe we want to sort by this. We could say select student name, or sorry, let's just select everything here. Select everything from students. Oops, I think my internet's a little wonky here. I'll select star from, let me give my code space a minute to breathe here. Going too quickly through these select. OK, I think we're back. So we'll do select star from students. And now I'm going to order by not student name, but by house. And so now I should see, if I zoom out, my data organized by house. I have all students in Gryffindor, all students in Hufflepuff, and all the students in Ravenclaw, and all the students in Slytherin. So the question now is, let's say we wanted to sort the student data in alphabetical order, but have it first sorted by house and then by student name. So ideally, we should have all of our data from our table viewed now, but sorted first by house, alphabetical order, and then inside of each house sorted by name. So how could we do this, do you think? If you want to chime in the chat. How could we have this kind of multi-layered sort going on? I'm seeing a few options, and one that I like here is this comma. We could use a comma, similar to what we did before. We could say, if we saw in select, we could do select, student name, and house. Or we could do the very same thing for order by. We could order by multiple things at the very same time. So let's do this. We could do select everything from students. And let's order by first house, and then by student name. So what the comma here is saying is that the very first thing before the comma is the first thing I will sort by. Then afterwards, student name is the next thing I will sort by. So inside of my sorted list of houses, I will then sort student names. So let's try this. And now we can see, if I zoom out, well, we have Gryffindor all sorted. And inside of the students who are in Gryffindor, well, we have those students in alphabetical order. C, D, G, H, H, L, N, and so on. So let's try it maybe with a more advanced technique. We could go in and say select everything from students. But now we just want to get the houses as they are, select order by house, and then the student name, but in reverse alphabetical order. And how can I get reverse alphabetical order now? Descending, right. So I could say DESC here, and now I'll hit enter. And now I see I'm still sorting by house alphabetically, G, H, R, and S. But now inside of each house, notice how I'm going from the bottom of the alphabet to the very top. So questions on these sorts? What do you wonder about? A good question. Is sort case sensitive? Let's check that one out, actually. So we can do select star from students. And now I'll do order by. And because we said house before, why don't we just try capital H, house? And I'll hit semicolon and enter again. And that still seems to work. So when you're talking about SQL column names, those also are not going to be case sensitive for you, right? And the question, what will happen if I switch between house and student name in that query? That's a great question. So before we had a query like this, select star from students. And then we did order by first house and then student name. But what if we did this? What if we did first student name, and then house? So what do you think will happen in this case in the chat? If you want to chime in, what do you think will happen if we flip this order now? Yes, so somebody says it will first sort by name and then by house. So let's try running this. We'll hit enter here, and I'll zoom out. And notice how my student names are in alphabetical order, but within the C's, for example, I now have my houses in alphabetical order. So Hufflepuff, Ravenclaw, and Gryffindor. Or let's see, we have a lot of M's, right? So here we have Ravenclaw, Slytherin. Well, that didn't seem to quite work in this case, actually. Why did that not work? M, R, R. Interesting. Oh, yeah, so somebody it's a good point. So somebody asked, there's no two identical names. So what would happen here is, this isn't quite useful for us, and I'll see if I can explain this, because what SQL will do is not sort by the very first letter of student name, but sort by the entire string. And so in order for the houses can be seen in alphabetical order, we have to have the exact same student name. So not just the same first letter, but the exact same student name. And because no two student names are exactly alike, we probably won't actually see the results in this case. So good catch from somebody in the chat here. Okay. Other questions on ordering then? A good question here. So what if a name starts with a number? Kind of unlikely, but a good edge case to consider. So if we had a name that starts with a number, well, it's going to go by the ASCII value for that number, I believe. So in this case, numbers would likely come before A, or become before, certainly before Z, and so on. So first numbers and symbols, and then the alphabet. And a question here, can we order one column by ascending and the second by descending? You absolutely can. So we could say this. We could say select star from students. Let's go ahead and order by house, descending. And then we could order by student name, ascending, like this. So certainly feel free to apply your own ascending or descending to each of these multiple kind of arguments to order by here. And another question before we move on. So one is, how are lower or uppercase letters sorted? So I think in this case it would be uppercase would come first, because I think uppercase is lower in the ASCII alphabet. If you remember how letters correspond to ASCII numbers, I think uppercase is lower there, so it would come first in the default ascending order of these characters. OK, so let's move on from ordering. And let's think about one keyword that's actually kind of useful along with ordering. And that's the use case of a limit. So if we have some query, and we want to get back just a certain number of rows from that query, all we could do is simply apply this limit 1, or limit 5, or limit 10, whatever number you want to limit at the very end of that query. And this is helpful for finding the top 10 of something, for example, because you can order by a certain column and then take the top 10 that show up. So let's go back to our query here. We could maybe say, we want the first 10 students whose name is first in the alphabet, the first 10 students from the very first alphabetically. So we could say select star from students, and we're going to order by student name, and then we'll limit our query to only 10 students. I'll hit enter here, and now I should see only 10 students, those whose names are the very first 10 in the alphabet. And similarly, I could change this. I could say, let's not get the first 10 alphabetically. Let's get the last 10 alphabetically. So I could do select star from students. Now let's order by student name, but in descending order. And then let's go ahead and limit 10. And we should see we get the very last 10 students in our alphabetical order. So limiting is helpful along with order by to kind of at the top or the bottom sort of segments of your data set, as long as you order by a certain column that you care about here. Question in the chat is, what if you don't have an ID and you select 10 queries, but you want to see the number? Is there a way to do this? Just so I can understand the question, I think we're talking about these IDs here on the left-hand side. And as we'll see later in section, these IDs are the primary keys, the unique identifiers for each of these students. And generally speaking, every student should have their own unique ID. If they don't have an ID, well, you might have some problems with database design. But if we're talking about ordering by here, order by student name, for example, we're not really caring about the student ID, just the student name in this case. We could certainly order by ID if we like to, like order by ID descending or order by ID ascending. But in this case, it so happens to be that the student ID corresponds to the student name kind of alphabetically sorted. All right, and I'm seeing a question with the last 10 students. So this actually is going to work somewhat similarly. So if I wanted the last 10 students alphabetically, I could do this. I could select star from students, and then go ahead and say I want to order by student name in descending order to get those bottom 10 students, and then, whoops, and then I could limit 10 at the very end. All right. Other questions too on limiting? let's keep moving then. And what we could do here is we often, it's nice to get the individual student names, but one thing we often care about is how many students are there, what's like an average test score, trying to aggregate our data, not just take individual rows, but see kind of the bigger picture from our data. And for that, SQL has a variety of keywords you can use to get that data, get that aggregate data, so to speak. So here we'll talk about aggregating, where aggregating means taking not just individual rows, as I said before, but kind of summing things up or averaging them or kind of seeing the whole larger picture. So if I wanted to count the rows I get back, well, we could do this. I could say select count star from students. And this will take everything in our table, first selecting everything, and return the count of it, the number of rows that I have. So for example, to figure out how many students are in this table, I could say select count star from students, semicolon, hit enter, and now I see I get 40 in this case. So there are 40 total students. And this is kind of not very pretty, like the count star. I'd love to say like number of students, for example. So how could I change this column name? Does anyone know in the chat? Yeah, I could use as. So I could say select count star as, in this case, maybe number of students. And then I could say we want to select that from the students table. So now I see I get the very same answer, but now my column is called number of students. So again, what we're doing here is selecting everything from our students table, counting it up, and returning that as a column named number of students in this case. OK. So what if we only wanted particular students? Like let's say we just wanted to count students from Gryffindor. Well, how could I do that in the chat if you want to chime in? Counting just students from Gryffindor. So I'm seeing the use of where, which is helpful. Other ideas too? Yeah, so I'm seeing I want to use count. I'll probably use where here too. And we'll get to what we call group by in just a moment. But let's try where first. So normally, to get all the students in Gryffindor, I would do a query like this. I could say select star from students, where, in this case, house is Gryffindor. And then a semicolon and hit enter. And now these are all the students who are in Gryffindor. But if I wanted just the count of these, not every individual row, well, I could modify my query and say not select star, but select count star. Select the count of everything here. Select count star from students. And then I'll say where, in this case, the house is Gryffindor. Semicolon, enter. And now I see I have 11 students who are in Gryffindor here. And that's all pretty good, but we also maybe care about Slytherin. So let's say we want to select the count star from students where the house is Slytherin. And that would give us also 11. But how could I get kind of all of the houses in one place? Like not just individual queries for each house for how many students are in them, but actually have it all in one query and have like a table that says Slytherin has this many students, Gryffindor has this many students. And I'm seeing in the chat this group by keyword that we're going to explore now here. So group by is helpful if you want to get the number of students by a certain attribute. So we want to kind of group our data by house and figure out, well, how many students are in each house. So let's try this. We can use group by as follows. I could say select star from our students table. And let's go ahead and group by, in this case, house. We want to sort of group our data by house. And I think we might have messed up slightly here, but let's go ahead and do the query. We'll just hit enter here. And now we can see, well, we have individual houses, but there's something weird going on with this like student name over here. We have much fewer pieces of data, but I'm not sure why we're getting student name over here. Well, instead of selecting everything, why don't we select the count from each of our houses? Select count again from our students table. And then we'll group by house. I'll hit enter here. And so I get back 11, 5, 13, and 11. What do you think this means in this case? Any ideas in the chat? It's the number of students in each house, but it's hard for us to tell which house is which. So let's include the house name in our query. So let's not just select the count of everything. Let's select the house in our query too. Let's order it like this. Let's first select the house, and then select the count of everything from students, as long as we're grouping by house. I'll hit enter here. And now I get Gryffindor, Hufflepuff, Ravenclaw, and Slytherin, where each one has a count next to it, like 11, 5, 13, and 11. So this is the total number of students in each group, as somebody in the chat is saying, that we're going to first group by house and then take the count by every house. Other questions on these group bys or this aggregation here? All right. So it seems like we have most questions answered there. And now that we've kind of seen a variety of SQL keywords, we've kind of reviewed them from lecture, let's dive into something about this database that probably isn't great for us. Like if we select everything here, select star from students, let's just zoom out a bit and think about what isn't very well designed about this database, if you take a look at it. What could be better designed about it? Or where do you see some repetition that we can maybe get rid of? Yeah, so I'm seeing some people saying that there's some repetition in the houses, right? We have Slytherin here, Slytherin again, Ravenclaw, Slytherin, Hufflepuff. Like a lot of these names are repeating. And similarly for the heads, notice how we have all the heads kind of repeated throughout this data set. And maybe ideally, we wouldn't actually have to repeat Severus Snape, all the way through our data set. We could just put Severus Snape in one place and reference Severus Snape from other places. And maybe for the house, we could say, well, Slytherin shows up a lot of times. What if we just had Slytherin in one table and we reference Slytherin in this table? So the goal is to avoid repeating ourselves over and over again in this data set, like having Slytherin so many times or Hufflepuff so many times. We might just want to make our own tables for individual pieces of our data set. So if we're thinking about how we could better design this table, let's look at a few design principles we could use to actually improve this table here. So I'll go back to our slides. Let's think about database design. So one principle for a database is that every table you have inside of your database should only represent a single entity. And we've actually kind of broken that rule here. So if I go back into my table, well, I have students in this table. It is a table of students, but I also have houses, I have heads. Like there's lots of things going on here that don't just belong to students, right? So ideally what we could do is try to simplify this a little bit. Let's try to have a single table for students, a single table for houses, and then a single table for the assignments of students between houses. So in this case, students wouldn't also have the house assignment, and similarly houses wouldn't have the house assignment, but we have this extra table called student house assignments that sort of tells us how these students and houses relate to each other. So as a visual here, let's dive in. Let's say this is what we currently look like, right? We have a students table that has student names, houses, and the head of each house. But we want to break this up. We only want to have a single thing inside of each of our tables. So let's break this up. Let's say get rid of the houses and heads here. Those are gone. Let's just have students in this table, right? But where should we put our houses now? Let's make a new table called houses. And this one we'll put here. We'll call it houses. And notice how in this table called houses, well, we have some new IDs for each of these houses. But now we have, well, in this case, it's called student name. Let me fix that. That should be house in this case. House called Gryffindor, Hufflepuff, Ravenclaw, and Slytherin. And then the head of that house in this case, like Minerva, Pomona, Phileas, and Severus. So we now have our own separate table for houses. And we could even go one step further and say, well, how do we now know where students are assigned? And for that, we could make our new table, this one called assignments down below. So you can see that I have assignment 1 to 4, where student ID is 1 and house ID is 4. So what do you think this table now is telling us down below? if I give you the full screen below here, feel free to type in the chat, what is this table telling us? Or really this first row. It's telling us that Adelaide Merton, belongs to Slytherin. How do you know that in this case? How do you know that Adelaide belongs to Slytherin now? Because of the IDs. So we saw before that here we have ID, student ID is 1. Well, which student has the ID 1? Well, it seems like it's Adelaide if we look in that table. And now we look at the 4 here for the house ID, and which house is 4? Well, that's Slytherin. So we know that Adelaide has a belonging to Slytherin in this case. Adelaide is assigned to Slytherin's house. So this brings us to another design principle here, which is that ideally, we only want to have every piece of data stored in one place, and then from thereafter, refer to that piece of data by its ID. So notice how we have in the students table an ID for every student, in the houses table an ID for every house, and now in our other tables we just have to reference that ID. We don't have to actually reference Slytherin or the student name anymore. If those things change, we change them in one place, and now the relationship we can sort of define elsewhere and update that as we need to. And this is a good segue into what people are saying in the chat, which is primary keys and foreign keys. So what is the primary key now in each of these tables? Where do you see a primary key? Yeah, so you're seeing in the ID columns for every table. So here in students' primary key, the unique ID for every student, is just that ID column. And for houses, the primary key is that ID column as well, and similarly for assignments. But now student ID is not a primary key, because it's not a unique identifier for every student here. What is it instead? It's a foreign key, so it's saying that this references a primary key in another table. This references the unique ID in students now. And similarly, this house ID 4, well, that references the primary key in houses. So what we're going to say is that the primary key is that unique ID inside of the table, and a foreign key is a reference to that primary key from another table, a separate table in this case. So if we wanted to update this table, we could do it as follows. Let's actually go through the work of trying to update this table. Currently, it looks like this, right? We have just a single table here, but we ideally want to make a different table for houses, a different table for assignments. So let's explore some syntax to actually make that happen for us. Now, we could create a table a bit like this, and something's missing here, but the general consensus is it looks a bit like this. We could say, create a table called houses that has three different columns now. One called ID, one called house, and one called head. So the table called houses will have a column called ID, a column called house, and a column called head. And what is this last bit doing for us here? Any ideas? What is that specifying about our table? That fourth kind of row here. Yeah, so it's going to say this is going to be our primary key. This is going to be our unique ID inside of this houses table. So ID should be always unique for every row. It should never change for every row. OK, so if you wanted to do this, we could try this, but it won't quite work for us. That's because in SQL, there are also data types. So if we create a new table, we have to say what kind of type we're storing in each of our columns. So here we might say not just ID, but that ID is an integer. Or not just house, but that house is a piece of text, and so is head, right? So now we're saying that we're going to have these three columns, ID, house, and head, and that ID is an integer, house is text, and head is text as well. And we could even get more fancy with this and apply some constraints, which means we could kind of make sure that as we insert data to this table, we adhere to some rules that we set beforehand. And maybe one of these rules is that each of these columns should never be null. Null meaning empty, meaning that every column, or every time we add a new row, no column can be blank, right? We can't have a house without a name, and we can't have a house without a head. That wouldn't make sense. So every row has to have each of these three columns in order for us to insert it, right? And so kind of a translation here is that not null is similar to required. We have to make sure this column name is required when we insert some new data here. So let's try this soon, but what questions do you have so far on this create table syntax? let me see. A good question here. So if we update the particular house's ID in the house table, can that update the ID in the assignments table? So let's go back to our visual here. It's a great question. If we looked at the ID for Slytherin, that is 4, right? And in the assignments table, we have the ID 4. Now, if I changed Slytherin's ID to be 5, well, this assignments table would not automatically update for me, at least if I do it naively. If I just go in here and I say that this row here, Slytherin, should now have the ID 5, that will mess this reference up. We won't actually know what to point to anymore. What I could do, perhaps that's better, is let's say, OK, Slytherin, perhaps it's no longer called Slytherin anymore. Maybe it's called a different kind of name. I could change this, well, this house now. Let me fix that typo here. Fix this house. And I could call it something else. And now, if I reference that same ID, I'll get a different name for this student house, right? But I should never change the primary key in general. And I see a question too about primary keys. So is it good practice to have an auto increment for the primary key? Meaning that if I add a new row, like let's say if I add a new student over here, that the ID automatically increases? Yeah, it's a great idea. We always want to make sure that our ID is unique. And so as we add new rows, we want to make sure they're always increasing our ID. And SQLite will handle that for you. So if I go back to my create table statement, and if I have this primary key ID constraint down at the bottom, that will mean that this ID column will always auto increment for me, and often it actually won't ever be null. So primary key handles some of these constraints for me by saying that, look, this column should never be null. It should also never be a random value. It should always auto increment as I add new rows. Great questions here. Other ones too? A good question here. So when we chose to distribute the database into 3 tables, why is this the best distribution? So if you go back to our visual again here, why is this the best? I actually won't say this is the very best we could do. There's probably some more updates we could make here. But this is simply better because in this case, we're reducing some of our redundancies. And I could more easily change my data set if I'd like to. So notice how here, going back to our example of changing some names of houses, well, if I change the name of Ravenclaw, in my prior data set, like this one, I would have to go through and update all of these names like individually. I have to find Ravenclaw, 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 update that every time. But if I have this kind of arrangement, well, I can just change Ravenclaw in one table. And now that name is changed out my entire database as I go through. So it's helpful to kind of not repeat ourselves while we're having these database design questions here. OK. So let's try actually creating this table now. And our goal was to create a table called houses that had some of these constraints here. So let's go ahead and go back to our SQLite database. And let's try it. Let's go ahead and create a table, this one called houses. And now I'll add my parentheses to say what columns should be inside of houses. I'll hit enter here. And now I'll, kind of by convention, indent 4 spaces. I'll hit 1, 2, 3, 4. And the first column I want to have, that one's called ID. That one will be an integer. And ideally, I want it to be not null. Never should be able to have a blank ID in this table. OK, next one. I want to have a name of the house, this one, some text. And I also want to make sure that I can't have this ever be null, never blank. And similarly, I want to have a head name, this one called this of type text, and also never null. And there's one more thing I need to add here. And what is that? A primary key. So I could say primary key ID, and then close this out down below. I'll end my parentheses and hit a semicolon and hit enter. And now if I type .schema again, well, I should see I have a table for students now and a table for houses. And what we could do if we have more time is spend some time actually updating this database, like take data from our students table, insert into houses, make sure the students table removes the house and head columns as well. We won't spend too much time on that here today, but the goal is simply to show you how we can add more tables and insert some data. But on the note of inserting some data, how could we actually add heads here? Because if I do select star from houses, well, there's nothing in there. Nothing shows up. So how should I add some data here? I'm seeing insert. So let's actually see what that could look like. I could go here, and I could say our picture right now is like this. We have a blank houses table that has the right column names, but no data. So let's actually insert some data. So in general, inserting looks like a bit like this. Insert into the table name, followed by some columns I want to add data into, and then some values I want to add to those columns. And to add in, let's say, Gryffindor, I could do this. Insert into the houses table on the house and head columns, Gryffindor for the house, and McGonagall for the head. So let's try that. I could say down below, insert into houses. And which columns do I want to insert into now for houses? Head and house. Although let's do it in the right order. Let's first do house and then head. Let's then do the values. Let's say, OK, what should go into the house column? Gryffindor. And what should go into the head column? McGonagall. And then we'll hit semicolon, enter here. And now let's select star from houses. And now we see Gryffindor as the house, and the head is McGonagall with the ID of 1. That primary key has auto-incremented for us. Let's maybe add now, let's maybe add now Slytherin. We could say insert into houses with the values Slytherin and Severus Snape. And now, if we select star from houses, we should see our ID has auto-incremented, and we now have Slytherin with Severus Snape as the head. So questions on these inserts or this creating tables? All right. A question about what if I want to insert more than one row at once? I believe that that is a good use case for something like Python. So we saw in lecture, not so much today, but in lecture, how we could use Python to kind of automate SQL queries. You could imagine, for example, having a Python loop, like a for loop, that kind of runs insert query command over and over again to add multiple rows over and over again there. So more on that next week when we work on, like, actually in later weeks, like with Flask and so on. But for now, I would refer back to lecture and look at how we can use Python along with SQL. OK, so to kind of close this out here, what we'll do is figure out how we can actually modify our queries to fit this kind of more complex database. Now that we have data in all kinds of different tables, well, how do we query it? How do we get actually the information we want to get out of it? Something like this in the very end. How do we get the data we want out of this? And there are a number of ways we could do this. And let's take a look at actually an already complete database. So I'll go ahead and I will get a database that I've already created here for you. I'll do roster.db, copy it here. And now if I do SQLite 3 roster.db, type.schema, you should see that now we have this brand new schema for our table. So we have a students table with a student name and an ID, a houses table with the house name and a head name and an ID, and then finally this assignments table where we say that a foreign key called student ID references the ID column in the students table, like this, and then the house ID column here references the ID column in houses, just like this. And if I select star from houses, notice how we have all of our houses and heads. If I select star from students, notice how I have all of my students and their ID. If I then select star from the assignments table, well, I then just see all of the student IDs and the house ID they belong to. So a bit more complex now, but the goal was to kind of reduce our repetition to make sure we have every entity in a single table. But how do we then get the data that we want out of this? Well, there are a few ways we could do it. One way is to use these selects and these joins. Maybe we want to actually try to figure out the number of students in Gryffindor. Like, how many students are in Gryffindor? We found that out before, but now we have this new schema, this new table organization. So how should we change our approach? Well, we could use these selects, and we can actually make sure our selects are kind of nested inside of each other, like have one select work first, and then feed the result to another select later on. So let's try this. Let's say I want to figure out how many students are in Gryffindor. Well, I should probably first notice that the ID column in houses corresponds with the house ID column in assignments. right? So maybe what I should first do is figure out, well, what is the ID of Gryffindor? And to do that, any ideas for a query to find out the ID for Gryffindor? What query could I use? Assuming I couldn't see it before. Assuming I don't know what that ID is, how could I find the ID for Gryffindor? Here's our schema again. So maybe one thing I could do is, I don't know the ID of Gryffindor off the bat, but I could try to select it. I could say select maybe the ID from the houses table where the house name is Gryffindor. And I'll hit enter, and I get back 3. And does that match? Let's see. Select star from, in this case, houses. And I see that Gryffindor in this case is 3, although admittedly over here it is 1, so that's a little confusing. But in our actual table, it is 3 over here. And now that I have the ID of Gryffindor, well, how could I find all the students who are in Gryffindor? I could try to do this. I could maybe say select the count of the student IDs, or select count of student IDs from the assignments table where the house ID in this case was 3, right? We know that Gryffindor in this table here is 3. I'll hit enter. And I get 11 students, which seems right? So this query could still be better designed, though, because here we're talking about this number 3, but what could we do instead? How could we maybe not hard code this number 3, if you recall from lecture? Any ideas in the chat? We could use a join. We'll see those later on. But what else could we do? I'm seeing some ideas of kind of nesting these queries. So as an example here, let's say we first run this query, right? Select ID from houses where the house is Gryffindor. Give us the ID of Gryffindor. Then let's feed the results of that query into a larger query, this one, the above. So here, notice how we have some parentheses saying that this query first will be run at the very beginning. The result of this will then be passed up to our larger query, our kind of our query that's kind of nesting this one. So I'll run this first query. I'll go back 1, at least in this table. And then I'll say that in this case, the house ID for Gryffindor is 1. And now the rest of the query itself completes. I could say select count of student ID from assignments where house ID is 1 in this case. So let's try it out. I could say select, I know at the very beginning, the count of student IDs from the assignments table. OK. But now I need to figure out what's the ID of Gryffindor. Well, I know I want a house ID, and I want it to be equal to something, but what is that something? What I could do in this case is I could say, well, I don't really quite know. I could say, well, go ahead and first find me that ID for Gryffindor. Select ID, in this case, from the houses table, where the name, or the house, is Gryffindor. And then I will go ahead and hit enter here. Close my query with a semicolon here. Hit enter. And I still get that same result. And this is better now, because if the ID of Gryffindor changes, like notice how in this table it's 3, but in this table it's 1. If the ID of Gryffindor changes, well, now I can just figure out what I'm looking for without actually caring what the ID of Gryffindor actually is. So thoughts or questions on these nested selects? What questions do you have? A question here, can we nest without any limit? You theoretically can have as many nestings as you want to have. So we could maybe have a query here. If I look up here, like maybe we don't know something about this query. We could say, OK, run another query to give me that result, and kind of nest them and nest them and nest them over and over again. You can absolutely do that. It comes at a cost, though, of performance, right? You want to make sure that you're kind of limiting your number of nestings to make sure you're not just looking up arbitrary data that you don't actually need in this case. So no theoretical limit, really, but there is a limit if you're concerned about performance, which you should be. OK, So this was one way of approaching this problem, counting students in Gryffindor with this new table using these nested selects. But another way that is maybe a little more intuitive in some ways is going to be this join that we saw earlier. So this will bring us almost to the very end of our section if we look at joins here. But instead of using select, we could use this idea of kind of putting these tables together, right? Here in our select, which we're treating them still as separate tables, but with joins we could say, let's actually put our tables together and think of it as one bigger table in this case. So if we look at our visual again, counting the number of students in Gryffindor, we're going to see something like this, where we have 3 different tables. But it would be helpful, like ideally as a human, we could just simply take these tables and like put them together, like just kind of like Legos, stick them together so they fit right next to each other. We can see which houses align with which IDs. So let's again notice that in this case, the ID column in houses corresponds to the house ID column in assignments, and we just want to sort of pair them up, like put them right next to each other and see that larger, bigger table. And that's what join does for you. So a join, once you run it, will look a bit like this. It'll put your 2 tables together and have them align based on the ID you specify. So here I'm saying, give me the assignments table and join houses onto it. So notice how on the left-hand side here, I see assignments, that is the assignments table, and I see houses, which is the houses table, but they're corresponding, they're now next to each other based on the fact that house ID in the assignment table corresponds to or references that ID column in houses. So SQL knows which rows to put together with which rows in each table based on this ID we specify. And the syntax for this looks a bit like this. We could say, select everything from the assignments table, but first join on the houses table and make sure we use this column as the corresponding column in this case, like the assignments.houseID, meaning the house ID column in assignments, and houses.id, meaning the ID column in houses, making sure that these correspond to each other in this case. So notice how I go back to our visual here. We have the ID column of houses corresponding to the house ID column in assignments. So let's try this in SQL. Let's go ahead and select star from our assignments table. But first, let's go ahead and join on the houses table. And let's join houses on a certain column. Let's say we want the houses.id column to match up with the assignments.houseID column. And here we do this. And if I zoom out a bit, you'll see the very same table. We have the student ID, the house ID, the ID of the house in the houses table, the house name, and the head. So what can we do now to figure out how many students are inside of Slytherin, or Gryffindor in this case? I'm seeing some longer queries, which is good. We could simply count up student IDs. I'm sure to do this, but let's try this one. We could say, I want to select the count of the student IDs that I have from the assignments table, right? But I first want to join in. I want to join in the houses table, making sure that, in this case, the houses.id column matches up with the assignments table with the house ID column. And now with that bigger table, well, I only want the rows where it seems to be that the houses house column, the house column in houses, is equal to Gryffindor. And I'll hit enter here. And now I get back 11 still. And I could do the very same thing for Slytherin. I could just change Gryffindor for Slytherin, or Hufflepuff, and so on. But the idea here is that we're trying to see our tables not as individual tables anymore, but now as one bigger table. And we can use that to figure out, well, what kinds of columns can I query to get the result that I want now? So what questions are there on these joins? Either on the syntax or how they look. A good question. So here we say, so it does not matter when we say join on a foreign dot table and a primary table. Let me try to parse this question. What we could do, notice how in this above query, I said houses.id equals assignments.houseID. And the reason for this was that if I have two ID columns in two tables, well, those columns are unambiguous in their own tables, but when I join them, those columns with the same name are now ambiguous, meaning that they have the same name and there are two columns. So we have to differentiate them somehow. So if we say houses.id and assignments.houseID, well, if I had two columns with the same name, like maybe it's just ID in assignments, I could say houses.id equals assignments.id, and therefore get the appropriate column name as we go through. A question about how not to show identical IDs, like the house ID in the house table and assignment table. So if I do this, go back to select star, select everything from our assignments table, joining in the houses table on houses.id equals assignments.houseID, assignments.houseID. Notice how we had some repetition here, right? We had house ID and we had ID. In the way that SQLite works, this is just the way that it joins tables. You're always going to get those duplicate columns here. But maybe helpful if you narrow down your select. You could say maybe not select everything, but maybe select the house ID. You could select student name and so on. So you could narrow your select, not select everything. But in general, when you join two tables, you are going to get those duplicate columns because SQL needs to know which columns to join by. That makes sense. And a good question, can we give an example of a join with a group by? So we absolutely could. So notice how, or remember how earlier in section we tried to have this group by that figured out how many students are in every house as a whole, like Slytherin, Gryffindor, all in one table. We could do the same query now, but with a join, with our separate tables. We could say, maybe first, select for me the houses, the house, like the actual house name, and the count of the student IDs in that house. And what I'll do now is I'll say I want to select that from the assignments table. But I want to first join in the houses table so long as the houses ID column corresponds with the assignments.houseID column. And now what I could do is I could just simply group by house. Or to be more specific, I could group by houses.house, the house column in houses. But I'll just say house for now for consistency. And I'll hit enter now. And now I see that very same thing. Gryffindor has 11 students, Hufflepuff has 5, Ravenclaw has 13, and Slytherin has 11. So good question there. If we just treat our join table as a regular big old table, well, we can do the very same arithmetic as before. A good question here. So can we use as when we join the two tables? Let's try it. So let's say select house, select star, sorry, from, let's say, assignments. And then let's go ahead and join on the houses table with houses.id equals, in this case, assignments.houseID. And the question was, can we use as here? Could we say as, let's just call all of this ID. And let's see what happens. So hit enter here. And I don't think we can do that because we're trying to kind of rename these columns as we're joining them. SQL expects the actual real column names, not the aliases that we're going to use while we're joining. So a good question there. Other questions on these joins? And for a visual for folks, if you are still wrapping your mind around this, it's helpful to sort of see, in this case, that we're trying to simply figure out which IDs are sort of matching up with each other, and this part of our SQL query is actually doing that matching for us. OK, can you join a table more than once is a question in the chat. You absolutely can. So if I wanted to have more than one table in my join, I could certainly do that. I could maybe get back my entirety of that original table we had before. I could say select star from students, right, originally. But then I want to join, let's say, the assignments table, where the, let's see, it would be students.id is corresponding to the assignments.studentID. Let me zoom out a bit. OK, so that join is ready. Now I'll also join to this table. I'll join on the houses table, so long as the houses.id column corresponds to the assignments.houseID column. And now I should get back my entire table, joining these two back together. And now it's kind of big and kind of redundant now, but I do see that very same table we had before, everything joined together originally. Can you alias table names? I don't believe, I'm not quite sure. You're going to try it out yourself. I don't think you would be able to do that in this case, often because they don't show up in the query itself, or the result of the query itself. Difference between a join and a union. We probably won't dive into unions so much here, but a union is good for finding out things that are in common with different data sets. Let's say you have one table and another, and both tables have some intersection, like data that's common between them. A union would be good for that, whereas a join is just good at simply combining your tables together as you go through. All right. Other questions on joins before we wrap up? And happy to stay after as well. OK, so why don't we wrap officially here? Okay, this was the end of our section for this week 7. Thank you all so much for coming. It was wonderful to see you over Zoom this week. Happy to stay around and answer questions in the chat. But otherwise, we'll see you in the future. Thank you all.
Recording stopped.
And thank you for all of your wonderful questions. I appreciate them in the chat. If you'd like to ask any others, happy to stick around for a few more minutes. And thank you for the congratulations. I appreciate that. A question on group by. So let's go back to that. The question was, how does group by work? What's the point of group by? It's maybe helpful if I show you how it would work in this context. So let's go ahead and join back to what we had before. Let's select everything from our students table. And let's go ahead and also join in our assignments table on assignments dot, in this case, student ID is equal to students.id. And let's join the, I'm trying to remember, the houses table on houses.id equals assignments.houseID. OK, so now we have our big table. But let's say we want to group that data or do something with that data within a certain group. So we could say this, group by. Often in this case, it makes sense to just group by house. And this is saying that if I wanted to count up anything or average anything or like figure out how many of something I have, well, normally if I didn't say group by, I would just get the count of all the students, right? But if I instead group by house, what I'll get, my code space is kind of glitching right now, but I will get back that same count, but only looking at the smaller subset of data within each group. So looking at every house individually and counting up within that house group, if that makes sense. And if that doesn't quite make sense yet, I encourage you to experiment with it more to figure out how group by works. And there's still some resources on the web you could learn from as well. Yep, and we will certainly share the recordings for these in CS50X 2023, so very early January as well. OK, so other questions here? A question about commands with capital case. That's simply by convention. So it helps us note between the capital SQL keywords and our column names here. So by convention. Whoops. Get rid of that. Are sorting and group by similar? Sorting is helpful if you like order by, that's an example of sorting. I could order my data, and that is kind of helpful for seeing groups in my data, like seeing what groups there are. But if I want to count something up within each group, well, I should still use group by in that case. So group by is often used with these aggregators, like count or average. Here I don't have that up here, but I would normally type like count star or average star and then a group by. So good question. OK, well, so glad this was helpful, and thank you all. Great to see you over Zoom. We'll hope to see you next week.